You might recall your grade 10 year after spring break, you folks were all doing virtual learning or remote learning or online learning or whatever we called it. I was teaching circuitry at that time. If you go to my website, what's my website? Click on Physics 12. And if you scroll down and click on 2019, 2020, scroll, scroll, scroll. This is where I started doing online learning. And what I did for each lesson, I did a video lesson. You're going to get that lesson in class, but if you're away, I'll post it online as well. I'm starting to put copies of blank notes online, but I did a complete solution key of the homework as a PDF and on YouTube. So for example, if you're working on some of the homework from lesson 4 and you can't get one of the questions,
I times R, so it's going to be
question 5, Mr. Dewick. Okay, let's go find question 5. Oh, there's question 8.
And I can tell.
Here we go. Oh, there is no question 5 on lesson 4. Whoops. But you can jump around and you can find a solution key for your questions, okay? And I think it should still be fairly similar. I've tweaked the lessons, but I don't think I added more homework. So, how do you get there? Again, pitmath.com. Physics 12, click on the 2019-2020 ones. Scroll down to where it says online learning starts, and this will be all the circuitry stuff. Or if you know you're going to be away ahead of time and you want to scooch ahead, there it is. Okay. Let's put everything together. Solving circuits. Mixed resistor circuits. What are mixed circuits? They have both series and parallel parts. To solve these circuits, first thing I always do is label downhill. Of course I do. It lets me write something down. It's a bit of a no-brainer. I feel better. Then I try to find the total current leaving the battery. If I can find the total current, trust me, the question's going to fall apart. Then I go, okay, now it's just a matter of being meticulous. I always look for any place in the circuit where I know two things. Any resistor where they've given me two pieces of information, because if I know two things, I know four things. Especially if I can find the current, that might help me find the total current. Then I ski. I use Kirchhoff's laws. Specifically, I try skiing loops from the battery chairlift and back to the bottom of the battery, so that all the voltage that I gained has to be all the voltage that I lost. As my last resort, step 5, I'll rewrite the circuit in its simplest form by using the rules for combining resistors. If they're in series, I can add them together. If they're in parallel, I add the reciprocal. Example 1 says, identify resistors in series or in parallel. I'm going to make up some numbers. These are not going to work out evenly. But let's suppose this is 5 ohms. Let's suppose this is 10 ohms, and this is 12 ohms. What if I wanted to write this as a single resistor? Sorry, it's not 5 plus 10 plus 12. I have to deal with the ones that are in parallel first. Which ones are in parallel here? The 10 and 12. So the first thing that I would want to do is I would like to find our parallel. I'm going to do a little sketch. So here, these two I'm going to represent with a single resistor. And I don't have much room, but if I write right here, 1 over R parallel, I'll use 2 lines for parallel again, is going to be 1 over 10 plus 1 over 15. I introduced the reciprocal button to you the other day. So it's going to be 10 reciprocal plus 15 reciprocal. Is the answer 1 point? Yep. Or 1 plus 12, sorry. Thank you. Don't know why I said 15. Can't even read my own writing. Which is a shame, because that was going to work out evenly. The answer is not 0.183. It's the reciprocal of this. However, there's a built-in error check. How big is this resistor right here? Mr. Duke, use the cursor. How big is this resistor right here? 10. How big is this resistor right here? 12. I know the answer is going to be less than 10. When you're writing resistors in parallel, the combined resistance will always be smaller than the smallest resistor. I get 5.45 repeating. Sorry. So yeah, we're using our reciprocal button because it's less work than writing 1 over plus 1 over plus 1 over plus 1 over equals 1 over answer. Got a lovely reciprocal button. So I know that this is 5.45. I'll even stick the repeating ohms. And here I have 5 ohms. How can I combine those ones? Now they're in series, and so now I could add them. I could say our total was 5 plus 5.45, 10.45 ohms. And if I knew the voltage, then I can find the total current, because I total is V total over R total. This is terribly messy, Mr. Dewick. Let's be a bit more organized. R total equals 10.45 ohms. Is that all right? What about this second one? How would I combine this? Again, I'm going to make up some numbers. Let's call this 4 ohms. Let's make this 8 ohms. Let's make this 8 ohms. Let's make this bottom one 4 ohms. And I don't know, let's make this 12 ohms. How could I write this as one resistor? Add the parallels? No, not yet. And the reason is these 3 are not in parallel with the 12. These 3 combined are the parallel with the 12. You know what this really is? These 3 are in series. Really, this circuit looks like this. Write this down. There's a 4. There's a 12. But this here is a 20. That's what that circuit is. Now I can combine the 12 and the 20 using our parallel. 1 over 12 plus 1 over 20 equals reciprocal answer. So now I could say 1 over our parallel is 1 over 12 plus 1 over 20. Our parallel equals 7.5 ohms. What's the total resistance of this circuit then? Well, these 2 here combined into a single resistor, how big? So really, this whole circuit, mathematically, is that. What's our total? Yeah, now I can say, I use digital ink just to erase that second branch. I would redraw it if I had room, but I just don't have room. Let's dive into some actual questions, okay? Ooh, by the way, what about, this one? You know what? First of all, if I call this R1, R2, R3, R4, and R5, can you tell me a pair of parallel resistors? I think you're right, but you said it too casually. Tell me one pair of parallel resistors, please. R2 and R3. They're parallel with each other. Also, you said and as though all 4 were parallel with each other, and I don't think you meant that. Also, R4 and R5 are parallel, so I could combine these as one. I could combine these into one. I could combine these into one. I could combine these into one. And then I would add 1, 2, 3, and I would find our total. Let's dive into some numbers. Example 2, which I think is the next page. Okay. Find all voltages, currents, and power usage. In other words, solve the circuit. Step 1 was label downhill. What was step 2? You might have to turn back a page. Find total current. Do you see amps anywhere? Okay. What was step 3? Look for a resistor that has 2 things, because if they had told me 2 things there and 2 things there, I could find the current. I could find the current, add it up, and I would have I total. Or if they had told me 2 things there, I would know I total. Is there anywhere, Caleb, they told me 2 things? Ski. How many volts? I don't know. How many volts? I don't know. Sadly, skiing didn't help. Come on, eraser. Something wonky going here. Let's come back, bring it back. There we go. I do know that these 2 will be the same voltage because the skiers split up right there and met up right there. So if this ends up being 5 volts, this will end up being 5 volts. That might come in handy. My last resort, I'm going to have to rewrite this. I'm going to have to combine this as a single resistor. So these 2 are in parallel. I'm going to combine them. And here's how you can show your work organized, but without being really, really crazy organized. Usually, I find our parallel right next to the parallel resistors. So over here on the right, well, you know what? Let's do it down here. I'm going to go like this. 1 over R parallel equals 1 over 10 plus 1 over 15. Can y'all look up for a second? I'm going to be really fussy. I see some kids, they put an equal sign here. Technically, you just said that 1 over R parallel is equal to R parallel. No, we're pausing, and then we're going to take the reciprocal of the answer. That's why I put an arrow there if I'm being really, really fussy. I won't take marks off, but I got to show you the right way. So what did you get on your calculator? What is R parallel? What can I replace that 10 and that 15 with? I think this might work out evenly. So, Alexis, what we're doing is we're going 10, hitting our reciprocal button, and Allie, you as well on your calculator, plus 15, hitting our reciprocal button. And your reciprocal button is either a little -1 or a 1 over x, equals, and then we're going the reciprocal of that answer. Y'all get 6? So, I'm going to argue, if I do a quick sketch, that this circuit is actually a 4 ohm and a 6 ohm. How does that help? What's R total? What's the total resistance of this circuit? Now I can find I total, because I total is going to be V total over R total. V equals I times R, I equals V over R. What's the total voltage of this circuit? It's the battery. What's the total voltage of this circuit? 20? What's the total resistance? 10? What's I total? This question's going to fall apart. I'm going to label I total on both of my diagrams, the original one, Allie, and my sketch. That's 2 amps. that's 2 amps. And up here, that's 2 amps. Oh, does that mean there's 2 amps going through each of these? It's splitting up. They'll add to 2. But you know what? I know 2 things. How many volts am I losing in that resistor? How'd you get that? I times R. Oh, how many volts must I be losing then in this middle resistor? How do you know? Now I can ski using Kirchhoff's laws. I gain 20, I lose 8, leaving 12. That got me to the bottom. I must have lost 12 going through here. Oh, how many amps am I losing going through there? Am I using going through there? Sorry, how many? No. If V equals I times R, I think I equals V over R. Pretty sure it's going to be 12 divided by 10, which you don't need a calculator for. Oh. How many amps over here on the right? How do you know? Got 2 amps coming in. 1.2 amps went this way. 0.8 amps must have gone that way. How many volts over here? I know it's 12 because of Kirchhoff's law, or I can go I times R, 0.8 times 15. Try that. Do we also get 12? Because that would be really nice. Are we done? Let's see. They said find all voltages. Have we? Find all currents. Have we? Oh, power usage. Well, power equals V times I. So I guess in this top one here, how many watts? 16 watts. In the middle one, how many watts? Sorry? On the right-hand one, how many watts? 9.6. And there, we've solved the circuit. Okay. So here was a good example of one where we had to redraw it. There was no other way to solve it. Example 3. Find all voltages, currents, power usage. Well, step 1, label downhill. By the way, over here on the left, current is flowing up. Which way are electrons flowing? Okay, opposite direction. Electrons are going this way. That might be a nice multiple choice question. Hint, hint. Step 2 was find total current. Alexis, do you see amps anywhere on this? Ah. Step 3 was look to see if there's 2 things. Decide, but do you see 2 things on any resistor? Ugh. Step 4 was ski. If this wasn't there, then I could say, oh, 30 volts, and I'd be in business, and I could then know 2 things. I could find the current here and probably work my way backwards. And sadly, skiing is not going to help me because I don't know how high that is or that is. I'm going to have to rewrite this. I'm going to do a sketch. So I have a 30 volt battery, 6 ohm resistor, 5 ohm resistor, what will I do with these 3? Why? They're in series. So it's the same as How big? That whole right-hand branch is the same as a single resistor. How big? And for what it's worth, look what we've just done. We turned it into this question. In this question, we had resistor, resistor, resistor. Resistor, resistor, resistor. So now what? Now I'll combine these by finding R parallel. Well, by finding 1 over R parallel and then reciprocaling. So 1 over R parallel is going to be 1 over 5 plus 1 over 20. Five reciprocal button plus 20 reciprocal button. Dope. 4. So really, I'm going to resketch the circuit one more time. This circuit is the same as a 6 ohm right there and a single 4 ohm right there. Now I'm in business. Sophia, how big is the total resistance of this circuit? 10? How big is the total current? Well, it's going to be the total voltage divided by the total resistance. It's going to be 30 divided by 10. Bet you can even do that in your head. I know total current. This question's going to fall apart. I'm going to label it everywhere that I'm allowed to. So I know going through here is 3 amps. Going through here is 3 amps. I know going through here is 3 amps. Sophia, are 3 amps going through this 5? How many amps right here? Are they splitting up? So are 3 amps going through this 5? No. Are 3 amps going through this 20? No. Up here, oh, but definitely 3 amps are going through here. Okay. Hey, Sophia, I know 2 things. How many volts? Ooh. How many volts? The 5 ohm resistor, how many volts? Gotta be 12. Has to be. I know 2 things. 12 volts, 5 ohms, how many amps? Say it again. 2.4? Oh, how many amps must have gone this way then? Don't use your calculator. 3 amps, 2.4 amps. How many amps must have gone this way then in your head, please, for the love of God? How many amps going through here? How many amps going through here? Knock, knock. Knock, knock. Knock, knock. I know 2 things. Boy, I thought you'd get it on the second one. Yeah, I know 2 things. How many volts? 7.2? How many volts? How many volts? You know what would be really cool? It would be really cool if these 3 voltages also added up to 12. Because they should. Does 7.2 plus 3.6 plus 1.2, does that equal 12? We must be right. Alrighty. Find all voltages. Check. Find all currents. Check. Oh, power usage. How many watts in that upper left one? How many watts in the top one on the right? $4.32. The middle resistor, how many watts? Sorry? The right-hand resistor, how many watts? And the bottom resistor? Are those all right, folks? And all we're using is V equals I times R, and yes, I equals V over R, and R equals V over I, and power equals V times I, and power equals I squared R, and anyways. Okay. This I would consider more of a B plus, maybe even A minus level question. B plus. Example 4. Here's a good using principles of physics question. There will be a using principles of physics question on your test. You can solve it algebraically or like intuitively if you want, or you can just make up numbers. And I gotta be honest, often I'll just make up nice numbers and crunch it because I'm pretty good at solving these. Example 4 says, what happens to the total current in this circuit when the switch is closed? You know what? Why don't we just calculate the before and after? So I'm going to go over here on the right, a little line, open, closed. When it's open, what's R total? So when this switch is open, that means this is not even part of the circuit at all. You could ignore it. What you really have are two resistors in series. What's R total? What's the total voltage coming from the battery? So what's the total current when it's open? So here's the question. When we close the switch, will that require more current, less current, or the same? I doubt it's the same. Will it require more current or less current? Well, let's first of all find our total. I guess to do that, Camille, first of all, we need to find our parallel. So if we close the switch, I'm going to have 1 over R parallel equals 1 over 5 plus 1 over 10. What can I replace both of those with if we close the switch? What's that the same as? 5 reciprocal plus 10 reciprocal equals reciprocal. I get 3.333333333. So basically, don't write this next bit down, but Donald, our argument is you have a single resistor, 3.3 ohms large, right there. How could I figure out what R total is?
You add 20.
Yeah. Donald, what was R total with the switch open?
25.
What about when the switch is closed?
23.
Did R total get bigger or smaller? Okay, here's the weird, so little circuitry for you. If you add a resistor in series, R total gets bigger. But strangely, if you add a resistor in parallel, you might think, well, I'm adding a resistor, so R total must be getting bigger. Actually, when you add a resistor in parallel, Donald, R total gets what? Smaller. Every time you add another parallel resistor, you've actually lowered the overall resistance. Oh yeah, you know why? You're opening up more ski hills. You're opening up more ski hills. So overall, the average resistance, even if it's a crummy ski hill, it's going to lower your average resistance because you can get a few more skiers out there. What's I total?
So 4.28.
How'd you get that? 100 divided by 23.333, right? There, I even used my answer button. 4.2856, call it 4.3, because we're just doing a using principles of physics question. What's the correct answer, A, B, or C?
C. B.
Someone said C, someone said B. The good news is A is wrong, and nobody said that. Oh, I'm sure someone did. What was when it was closed? What was the current? First of all, when it was open, what was the resistance? Sorry, what was the current? 4. When it's closed, what happened to the current? Okay. Yeah, because I've told you current is like skiers. If you open up an extra ski hill, if you had another resistor, you can get more skiers on the mountain. Even if it's a high resistance hill, you're still going to get more skiers on the mountain if you add them in parallel. It says explain your answer. We did up here. We solved it. Okay. What's your homework? 1 is good. 2 is good. 3 is good. 4 is good. 5 is good. I'm putting a little star next to 5. 5 is drawn weird. I might redraw 5 to make it a little easier to follow, but you might be okay. 6 is good. Ooh, 6 is asking you to find the battery. Okay. 7 is good. 8 is good. We'll skip 9. Okay. It's 12:34. Probably at about 1 o'clock, I'm going to bring us back. Excuse me. Probably at around 1 o'clock, I'm going to bring us back. Lesson 6, all we're going to ask is, hey, what if you have more than one battery? Or, spoiler alert, what if you have more than one chairlift on the mountain? And the nice thing is, it will work like you hope it will work. It will work in the same way a chairlift would work, depending on where you put the chairlift. Okay. Pause.